Thanks for the introduction, Tim. So a quick show of hands before I begin my talk. How many of you have used ARKit before? Okay, so that's a good number. Last year, I co-authored a book called ARKit by Tutorials, and in the process, I developed 2 AR apps. So this talk is going to be about my experience working with ARKit, the challenges I faced along the way, and some practical tips to tackle them. So in 2017, Apple made a really exciting announcement that they're going to release a native framework called ARKit for delivering augmented reality experiences on iOS. AR had been around for a long time, but all the legacy technologies used a lot of external sensors and cameras to get AR on mobile devices. Some of the examples of these technologies were Google's Project Tango. But ARKit greatly reduced the barriers to entry and made it very cost-effective to get AR on mobile phones. So right after the WWDC in 2017, Ray from the RayWenderlich.com website sent out an email saying that he wanted to publish a book on ARKit, and I was selected as one of the authors. So before we do a deep tech dive into ARKit, I want to demonstrate the 2 apps that I made. So there were a lot of great ideas that people were experimenting with after ARKit was released, and I decided to do a Portal app first. This was also because I really enjoyed playing the game Portal, developed by Steam. So this was a pretty basic app. It would detect a horizontal plane, and then the users could touch anywhere on the plane to place a portal. I used SceneKit to render the walls and the ceiling and floor of the portal, but you can also use other native rendering frameworks like Metal and SpriteKit. They're easily integrated with ARKit. The other app that I made was called ARSketch, and this app was made basically to demo the persistence and sharing features of ARKit 2.0. So this app let the user sketch on any surfaces that it detected, and you could even save and load your previous sketches and collaborate with multiple users on the same sketch. So as you can see from these 2 apps, the augmented reality experience as a whole consists of a few key components. One of them is being able to detect and understand the physical surroundings of the device and being able to map the geometry of these surroundings. Also, one of the other important aspects is being able to render realistic-looking 3D virtual content in the scene. And finally, one of the major components that is not emphasized enough is guiding the user throughout this process and providing enough feedback to them so that they can improve the quality of tracking and detection that ARKit is providing. So I would like to start off with a few best practices that Apple recommends for getting AR working on iOS devices. Let's start with which devices ARKit is compatible with. ARKit can only run on devices with the A9 processor or later, and on devices running iOS 11 and above. So if your app's basic functionality is providing an AR experience, then Apple mentions that you should declare the UI required device capabilities key with ARKit as one of the capabilities in your app's info.p list. This ensures that your app is made available only to devices that are ARKit enabled. However, if AR is a secondary experience for your app, for instance, you have an e-commerce app where your users can buy furniture and you want them to be able to visualize the piece of furniture in a room, then this would be an optional AR feature for your app. In this case, you can simply check the is supported property of the AR tracking configuration that you're using to see if the device supports that AR feature. Also, if it does not support your AR feature, you can just not show the UI that leads them to the AR feature to provide a seamless experience. Another important thing to remember here is AR face tracking configuration needs the true depth camera to function, and it only works on iPhone 10 devices. So it's really important that you use the is supported property to check if it's supported on the user's device. The camera is core to the AR experience. Users must explicitly grant permissions to the apps to access their camera on iOS devices. But ARKit actually automatically asks for permission when it first runs the AR session. So all you need to do, all that Apple recommends you to do, is include the NS camera usage description key in your plist and provide a relevant explanation as to why your app needs to access the camera. If you're going to use AR face tracking configuration, it's crucial that your app has a privacy policy detailing how your app is going to use the face tracking data that it's capturing. This is highly sensitive information as it's personal facial information. So it's really important that you include this in your apps. So now that we have covered the minimum requirements for getting ARKit onto a device, let's look at some of the challenges that I encountered and some practical tips on tackling them. Tracking is one of the core features of ARKit. How does ARKit remember to keep the virtual devices where you have placed them? It uses AR anchors for this. AR anchors are reference points in the real-world coordinate system. And over long, extended periods of time, you will see that there is a drift in the augmentation, but ARKit provides a tracking algorithm that automatically adjusts these AR anchors for this drift. So it's highly recommended that you use AR anchors and not use feature points for placing your 3D content. So I have an example here of the portal app again. I've already placed the portal, and I'm walking out to show the portal opening from various angles and to show how well ARKit is tracking it. It pretty much remains in the same place, as you can see, as I'm walking away from it. So tracking quality is really important for delivering a smooth AR experience. How do you ensure that tracking doesn't fail? Good environmental lighting is essential for getting a good tracking quality. Having a bright, well-lit room would be the perfect environment for ARKit tracking. Whereas having insufficient lighting, such as dark rooms, would get in the way of the camera being able to discern different feature points in the scene. Also, it's important to have static, stationary environments for ARKit tracking to perform well. So by static environments, I also mean that objects in the environment shouldn't be having too much excess motion, as well as the environment itself should not move. If you're using AR in a moving elevator or a moving vehicle, you'll start noticing that the augmentation of the 3D content is drifting. This is because under the hood, ARKit uses camera and motion data together to do the tracking. But what happens in a moving vehicle is that there is a discrepancy between the two because the camera imagery is staying the same, but there is a lot of motion being detected. So the tracking algorithm gets confused. So this would be a perfect stationary environment. The other thing to remember is the device itself should not move too much because that can cause blurring in the camera imagery. And glossy textureless surfaces would be pretty problematic for the ARKit algorithm to do detection and tracking. So you should instruct your users to move the device to find more textured surfaces. And finally, ARKit relies on a continuous stream of camera and motion data. So if this data gets interrupted, the tracking quality can be limited. The tracking quality results are sent to the AR camera object in the corresponding AR frame. The AR camera objects provides us two enums. There's the tracking state enum and the tracking state reason enum. You can leverage these two to provide an appropriate message to the users on how to improve their AR experience. So here is an example of how I'm doing that. So I found this switch block pretty useful to convert from the tracking state enum to an appropriate feedback message for the users. Now, let's look at some of the features of ARKit 2.0. ARKit 2.0 provides us an easy way to save and load the virtual content that you've added to the scene by using something called AR wall map. This map captures the space mapping of the device's surroundings, as well as all the anchors that were placed in the scene by ARKit itself or by the user. This AR wall map object is serializable, and you should use a secure coding protocol to archive it, as this provides your app necessary security against object substitution attacks. The world map also has a mutable list of named AR anchors, and these AR anchors can be customized to store the state and position of the 3D objects that they correspond to. So for an accurate reconstruction of your 3D content, you need to be able to capture a reliable wall map. How do you go about doing this? One of the key things here is to find out the right time to capture this wall map. And just like the tracking status, you have something called a wall mapping status, which is provided in the AR frame. And this AR frame is updated continuously in the AR session delegate callback method. You can leverage this wall mapping status to also determine when to show the UI to the user to save their experience. So here's an example of the AR Sketch app where I only make the Save Experience button at the bottom of the screen visible whenever the mapping label on top reads mapped, and when it goes back to limited or unavailable, then the Save Experience button disappears. So now that we have covered some of the core features of AR and some obstacles that I faced, let's look at the performance considerations you need to keep an eye out for. So as with any other app, you should be testing your AR experience, and in less than ideal conditions as well. So take your AR app to a dimly lighted place or a moving environment, and ensure that your user is getting enough guidance to improve their AR experience. After you use ARKit for some time, you'll notice that it takes a considerable amount of time to do surface detection and real-world understanding. So you need to manage your user's expectation during this phase. And personally, one of my biggest challenges was getting ARKit to detect planes when my dog kept video bombing the app all the time. And she actually looks pretty close to this emoji. This is how she looks. Oh, can you not see the... Sorry, I didn't know it wasn't visible. I don't know what's happening. Do you know why the slides are not visible? So can everyone hear me now? Okay, great. So let's move on. ARKit is a session-based API. So at its core, it uses an AR session. AR session is pretty resource intensive as it's constantly capturing and processing camera and motion data. And it's performing expensive computation on this data to adjust for drifts and augmentation. The camera is also always active and it's constantly autofocusing. So you can quickly see that this is going to lead to a pretty big hit on your battery. So you need to keep this in mind and free up these resources whenever your app is not using them. So for instance, when your app gets backgrounded, you should free them up. Or if AR is a secondary feature of your app, then when the user quits the AR experience, you should free up the camera. So a wise woman once said, there is such a thing as having too much of a good thing. And this applies to AR anchors. While AR anchors are great to use, you should limit the number of AR anchors you're using in your AR app. When I was implementing AR Sketch, I used anchors for each of the points on the line that the users were drawing. And when I profiled it using instruments, I could see that it was taking a lot of CPU time, and there was a lot of threads being used as compared to the Portal app, or the same duration. And I think this is probably because of the visual inertial odometry corrections that it's applying to the AR anchors. So sometimes when using ARKit, you might experience that the virtual content disobeys the laws of physics. It might pass through real-world objects, much like a ghost passes through a door. This is because ARKit doesn't provide occlusion support out of the box, except for when you're using AR face tracking configuration, because it uses the true depth camera, which provides depth sensing. So you can actually implement this yourself using depth shaders if you wanted to. Another limitation of ARKit is that it's not able to map environments at a distance. The environment that you're mapping needs to be close by. So I have an example showing how it performs. Observe the mapping label on top of the screen. It shows limited when I'm pointing far away from me. But when I get the camera pointing closer to the objects near me, it shows that it has mapped the environment. ARKit by default uses 60 frames per second. But it's a good idea to lower frame rate if you're able to, because that will save you some battery. You can do this by setting preferred frames per second on the AR SCN view if you're using SceneKit. And the 30 frames per second frame rate is minimum recommended by Apple. So those were some performance limitations that I came across. I have a few other considerations to keep in mind while using ARKit. Pay close attention to where the delegate callbacks are occurring. And a lot of the times, you'll find that they always occur on a private queue. This is true especially for the AR SCN view delegate, which you'll need to use if you're using SceneKit with ARKit. So if you want to update any UI components or do updates to your scene nodes, then you need to dispatch all of this work on the main queue. And finally, if I want you to leave with one specific thing from this talk, it would be setting up your users for success. Always keep providing feedback to your users and guiding them throughout their AR experience. So, like in these examples, show them the output of the AR processing so that they know what's going on and they don't get frustrated. And thanks a lot for coming to my talk. If you want the slides, you can download them using this link, or you can find them on my GitHub. And if you have any questions, please meet me after the talk. And I would like to mention a quick thank you to Zynga, where I work. They have sponsored this event. And also, we have a lot of job openings if you're interested in applying, so check out the website. Okay, great.